Hi, today we are going to learn what we call a double inequality in math. We have learned about the concept of inequality, and we talked about how if two expressions are linked by the symbols greater than, less than, greater than or equal to, or less than or equal to, then this expression is termed an inequality. In math, there's also the notion of double inequality. Before that, let's write down a number inequality. We are talking about the fact that 5 is greater than 3, and this is a valid numerical inequality. Let's write another inequality that features the number 3. In this inequality, the number 3 will be greater than any number. Let's write the number -1. Hence, we have two inequalities. 5 exceeds 3, and 3 in turn exceeds -1. We can represent these two inequalities as a single one, but only if we remember that in these two inequalities, the same number is repeated. This number is 3. How can I write these two inequalities as one in mathematics? By employing double inequality. How does this double inequality appear? The truth is that we assert 3 is greater than -1, and 3 is below 5. Thus, when I refer to the same number we are comparing, and comparing it with different symbols, we can write it like this. 3 is larger than -1, but smaller than the number 5. Then, this way of writing inequality is known as a double inequality. In mathematics, one can write expressions and link them using double inequalities. I want to point out that I started with the number 3. I am saying that 3 is greater than -1 but less than 5. This is what is called a double inequality. You might wonder why we can't say that -1 is smaller than 3 and 3 is smaller than 5. I agree, it can be read that way, but in math, this expression is termed a double inequality. This inequality is read starting from the number placed between the two inequality symbols. 3 exceeds -1 yet is less than 5. Therefore, we refer to a double inequality. I would like to highlight that. The double inequality is not commonly recorded this way in mathematics. 3 is greater than -1 but less than 5. In theory, this is also a double inequality, but in mathematics, one must write this is like this. Initially, I announce the greater number, and afterward I go back to the lesser number. Of course, this inequality can be illustrated on a number line. Let's demonstrate it. And let's pay attention to the fact that we have three numbers, -1, 3, and 5. When we solved the inequality, it didn't matter where we placed one. A point at this coordinate. Here, we have three numbers, so I need to arrange them correctly on the line. Therefore, I state that the number -1 is positioned to the left of the number 3, and the number 5 is located to the right of the number 3. Thus, on the number line -1, 3, and bytes 5, I can see that the number -1 is actually to the left of the number 3, while the number 5 is to the right. But of course, we need this representation to solve double inequalities. Double inequalities can be expressed using strict signs, greater, less, or using non-strict signs. In this case, I will use a variable to write. If I mention that I have a number x, that is greater than -1 but less than 5. On the line, I will show two numbers. This one, let's set it to be greater than or equal to -1 and the number 5. Next, we need to determine all values of x that are greater than -1 but less than 5. We understand that these numbers are located between the number -1 and the number 5. Then I can express the solution to this inequality as a numerical interval. I will write that x belongs to the interval from -1 up to 5. When we solved inequalities and recorded the numerical interval, it was always written with -infinity and +infinity. But we will also solve examples where our variable's value will be located between two numbers. But in this case, we will talk about double inequalities or solving systems. But that will be in the next lessons. And for today, that's all from me. Goodbye. See you again.